Hi, everyone, and welcome to Natural Resources Canada's NRCan e-training module on energy efficiency expert evaluations, referred to as E4s for short. This course has been adapted from the U.S. Department of Energy's Federal Energy Management Program training material on implementing deep retrofits. This training is being delivered through the Natural Resources Canada Greening Government Services to help federal departments and agencies plan and implement projects that reduce the energy use and greenhouse gas emissions in their buildings, laboratories, and other facilities. Over the years, Natural Resources Canada has been successfully developing comprehensive methodologies, practices, and tools to reduce energy consumption and greenhouse gas emissions for the private and public sectors, including the federal government. Since 1991, NRCan has provided enhanced technical support to Government of Canada organizations seeking ambitious greenhouse gas emission reduction actions from their building and fleet operations. This training will support federal organizations to meet their commitments and lead by example. Federal facilities have committed to reducing emissions from their operations by 40% below 2005 levels by 2025 and by 90% by 2050. As outlined in the 2020 Greening Government Strategy. This initiative also supports the commitment by Canada's federal, provincial, and territorial First Ministers to scale up efforts to transition to highly efficient buildings and zero-transmission vehicle fleets as specified in the Pan-Canadian Framework on Clean Growth and Climate Change. Let's start by taking a look at the core competencies you'll gain by taking this course. After taking this course, you'll be able to manage an energy efficiency expert evaluation in a federal facility, uncover root causes of problems and develop practical solutions for facility energy and water efficiency improvements, and employ strategies from energy assessments, building recommissioning, and retuning. Here is some key terminology that will be used throughout the course. We will often refer to energy performance contracts, or EPCs. These are agreements between an energy service company and a client organization that are used for energy efficiency retrofit projects. Under this agreement, an energy service company assesses a facility's energy systems and equipment, identifies possible energy savings opportunities, recommends and implements energy efficiency improvements, and monitors the results and guarantees the energy savings. We will also refer to ECMs, energy conservation measures, that are applied to a building that improve energy efficiency and are life cycle cost effective. It is also important to understand the differences between commissioning, retrocommissioning, and recommissioning. Commissioning is the quality assurance process that begins during the design of a new building and continues through construction, occupancy, and operation. If a building was not commissioned originally, retrocommissioning can later occur. Finally, recommissioning is a re-optimization process for buildings that have already been commissioned. It is done to ensure that building equipment and systems are operating optimally to meet current occupant needs. So what is an Energy Efficiency Expert Evaluation, or E4? The E4 approach was developed several years ago by the U.S. Department of Energy to identify low-cost solutions to help federal facilities decrease their energy use intensity. An E4 combines energy auditing and retrocommissioning in a comprehensive and multidisciplinary approach to energy evaluations that involve people with different areas of expertise. It provides a neutral and unbiased review of the facility equipment, and the problems that the facility is encountering. It focuses on root causes rather than symptoms, and by design it also follows a common sense philosophy. The primary goal of the E4 is to decrease energy intensity. The sub-goals are to increase energy and water efficiency, to improve operational efficiency and system performance and achieve cost savings. The results of an E4 are no-cost and low-cost improvements to the facility and to the issues that it faces. There will also be a prioritized list of energy conservation measures, called ECMs, with cost justifications, and the final report will have justification for alternative funding requirements. We indicated earlier that E4 combines aspects of an energy audit and retrocommissioning. During an energy audit, you will be looking at things like lighting and the building envelope. You might take note of things like occupied spaces that are too bright, or unoccupied spaces where lights are left on. You would assess the building envelope and look for seepage through the windows and the doors. You're not going to spend much time concentrating on how much air is coming out of a supply register or the temperature and humidity settings in a particular space. During a retrocommissioning, however, you would be more concerned with these later aspects. You would be asked questions like, is the equipment operating the way it was designed to? Are you getting the right airflow out of the air handling units, and are the temperature settings correct? Are you providing the right type of pressurization in the spaces? You would not be as concerned about energy savings, although that is a desired outcome. However, there could be a situation where, in order to make a piece of equipment operate correctly, you actually increase the energy use. For example, you may have to add booster fans to the distribution system. This would improve performance of the system, but also increase energy use. What the E4 does is it takes the best attributes of energy audits and retrocommissioning and combines them for better overall outcomes. So the next question is, who does an E4? One option is to do it with internal on-site staff. The advantages of this option are that it's relatively low cost to use your own staff, and it's a sunk cost since they are already on site. This also makes the logistics easier. Another advantage is that staff already have intimate knowledge of the buildings and the equipment. They know the history, the background, how often the systems break down, and what the common complaints are. However, the disadvantages are that sometimes in-house staff are too close to the problem. Let's say over the years something has been jury-rigged because it broke down and the staff did not have resources to fix it properly. After a while, it gets forgotten and this situation becomes the new normal. Since the technicians see this day after day, they become too close to the problem to recognize it. There can also be a lack of objectivity on the part of some of the workers. There's also the possibility of fear of reprisal. If a staff member was responsible for a problem that gets discovered, they might fear reprisal if their mistakes are exposed. Another disadvantage of using on-site staff is interruptions. A common problem with using in-house staff is that they are unable to dedicate 100% of their time to the effort. For example, they may often be called out to meetings. If you use your own staff to do the work, they may have higher priorities. The second option is to use outside experts and consultants, and again, this has advantages and disadvantages. An advantage of using outside staff is that they will probably be more experienced and have sufficient experience doing energy audits and retrocommissioning, so they can bring to the table the lessons learned and best practices that they've observed elsewhere. They will probably have special expertise they can share. For example, there could be a member on their team who is a controls expert, since very few sites have a controls expert on their staff. And of course, they will bring additional personnel, so you do not have to take your staff away from their regular duties. The disadvantages include the higher cost of hiring external resources and also the learning curve, since many of these experts will not have historical knowledge of the buildings or the equipment. In most cases, we would recommend using outside experts and consultants to undertake the E4 process. There are 4 phases to doing an E4, and these are similar to the phases you see in an energy assessment or retrocommissioning. These phases are planning, discovery, correction, and handoff. We'll start by going over the planning phase. The first step in the planning phase is the department or client needs to identify a way of determining their success at implementing the E4 evaluation and in reducing their energy use intensity. You would start by understanding performance goals that normally address items such as operation improvements, energy and water savings, indoor environmental quality, environmental impacts, maintainability, and sustainability. Next, you look at the E4 process specifically and develop project objectives. You might want to focus on low-cost and no-cost solutions. You might want to set your focus on reducing energy use intensity or define metrics to evaluate how much energy you are saving. You will also need to provide justification for any alternative financing you receive, such as EPCs. You will then need to create a multidisciplinary team. A typical team will consist of a mechanical engineer, a controls engineer, and an energy engineer. Building occupants could also be brought into the picture when appropriate. For example, in a laboratory facility, you would want to talk to the researchers working in the building. They are the ones who can tell you what the correct temperature, humidity, and pressure should be in the lab to support their experiments. This is information that the facility staff would not necessarily know. Here is an example of the overall team that would be participating at various points in the E4. There are the engineers, the O&M staff, and the facilities and energy management staff. These are the folks who will be able to tell us about the facilities and the problems within the facilities. There are the employees and the building occupants. They are the ones that are the recipients of the temperature and conditions within the building. They will be able to share what their goals are and how the environment inside the building affects their goals. And finally, there are the E4 external experts. Once the team is in place, the next step in the process is to have the team develop a questionnaire. This will be sent to the facility staff approximately 5 or 6 weeks prior to the site visit. The questionnaire covers very basic information. The first item on the questionnaire is about the facility itself. We want to know the age and size of the facility, how many people are working there, and what the operation hours are. The second part of the questionnaire is about utility data. We want to go over utility data for a 36-month period to determine how much energy is being used for different types of utilities: electric, natural gas, water, etc. The third part of the questionnaire is to get information on the facility's maintenance program. We want to figure out how much of the maintenance program effort is put into preventive maintenance and how much is put into predictive maintenance and doing repairs. Finally, we want to find out what the biggest issues are at the facility. This is probably the most important part of the questionnaire. We want to identify what the facility staff perceive as the biggest issues. Are there hot and cold spots? Is there a constant upward trend in utility bills? Gathering and going over this information before visiting the site enables us to determine where to put our efforts. At the same time, you would request key documentation from the site. Ideally, you would look at the utility bills and the equipment inventory prior to going to the site so that you have an idea what to expect. During the assessment itself, there's other information that you are going to need to have available. It's helpful to look at the baseline data, and having access to engineering drawings is also very important. If any problems are uncovered, it's best to be able to look at the drawings on the spot. O&M manuals and building histories where there's been mission changes or space changes are sources of information needed to make a proper assessment. At the end of the planning phase, you will have set up your objectives and know what the metrics are. The team will be assembled and key documentation analyzed. The questionnaire will be submitted and completed and returned to the team so that they are well prepared before going to the site. Next, we'll look at the primary activities that take place during the discovery phase. Generally, the discovery phase is a 2 to 4 day fact-finding event depending on the building type. There can be big differences in the requirements between a warehouse, an office building, and a laboratory of the same size given the nature of the systems. So, 2 to 4 days to complete the discovery phase is just an estimate. The site itself will have a customized evaluation. At the start of the discovery phase, there will be a kickoff meeting to gather as much information as possible and to establish consensus among the groups as to why they are there. There would be a walkthrough tour to familiarize the team with the site. Then a more detailed site visit would follow, using diagnostics and going through the details of the building. The goals of the discovery phase are to uncover the root causes of energy waste, to move from problem identification to solutions, to do an in-depth investigation along with diagnostic and functional testing and analysis to identify no-cost, low-cost, and other opportunities for both energy savings and system effectiveness. There are 5 key areas of discovery where you can often find opportunities for energy savings and improved efficiency. System design. A facility had been suffering with the air conditioning problems over several years. Finally, after putting up with the faulty air conditioning system, they purchased and installed a new air conditioning system that happened to be a newer version of the old one. By putting in the same air conditioning system without considering its design, the site continued to have problems. No one ever thought about trying to figure out what the root cause of the problem was with the old system. Installation issues. Often we look above the ceilings and find that a duct was never properly connected or other similar issues. Building configuration issues. There may be changes to the configuration of the buildings. Quite often you will find that the layout of the facility has been changed and the function of the facility, or an area within the facility, has also been changed. There might be temporary partitions put in or removed. The spaces could have been completely reconfigured, but it's not all that common for the air distribution system, for example, to follow the same sort of changes that have been made to the space. Maintenance issues. A common maintenance issue is software maintenance and revisions to the software. Look at the control systems. If it's been under a contract for several years and for some reason the vendor leaves, they often don't leave behind the codes to get into the control systems, so the site is now unable to control even the most basic changes to their systems. Workforce culture. What is the culture? For example, are they supportive of training? Technology is changing rapidly, and it's not unusual for each piece of equipment to have its own technology that the workforce would need to be trained on. You can have a workplace culture where there is a belief that you should buy the cheapest equipment you can. These workplaces are concerned with the initial upfront cost. This is seen frequently with the electric motors and is also seen with other equipment such as filters. So it's important to take a look at these 5 key areas before jumping into E4 evaluation. The first thing the team will do once they get on site is to have a kickoff meeting. This may be the most important part of the entire process, to establish objectives. During the kickoff meeting, the team is introduced and the objectives of the E4 are discussed. The meeting brings together all the different players that might have a stake in the E4 evaluation. This typically includes building managers, facility managers, technicians, and occupants. The team reviews the completed questionnaire line by line to start probing and gathering multiple perspectives on the issues identified there. Generally, the most important or revealing part is the section of the questionnaire that identifies the biggest problems within the facilities. This is where you might find out, for example, that the first office in a line of several offices is always cold, and the last one is always hot, and the person in the middle is the one controlling the temperature. These are the type of issues that the building occupants would bring forward, but something like this would often be new information to the facility managers and other folks in the room. Often this will be the first time they've heard of such an issue. There would then be a walkthrough. The idea of this tour is to get an overall feel for the facility, what its uses and occupancy patterns are, how old it is, and how old is the equipment, and what are the O&M practices being followed in the facilities. As you are walking through, you will talk with the occupants. You will ask them questions on how comfortable they are and what issues they see with the buildings. Again, the more information that we get, the more qualified we will be as far as being able to get into the details. You would also observe very closely the facility conditions as you're walking through. The walkthrough tour is also a good time to do one-on-one interviews with the technicians as they explain the facility. Before you start, it's important to work with their schedules and routines so your visit is respectful of their time and not intrusive to their priorities. Often during more informal one-on-one discussions with the technicians, you can uncover information that is different from what came out at the group interview and the kickoff meeting. There may be subtle nuances or very different information that comes out once individuals have a chance to speak candidly. It is important to listen carefully and ensure to apply a no-fault policy to the discussions. You should also be sure to maintain a non-judgmental attitude during these one-on-one discussions and respect their privacy, so they know that what they are saying won't get back to the people that could potentially have influence over them. Throughout the entire process, from the initial briefing onwards, the E4 evaluators should practice active listening. The staff should understand that the evaluators are there to make their job easier. As the group is walking around, the team should stay together and listen as a group. The group will have a certain expertise, such as a mechanical engineer, energy engineer, control engineer, etc. This will give you the opportunity to hear a lot of different perspectives, and this can prompt more questions. Therefore, it's important to stay together as a group. This also comes in handy at the end of the day, as you can compare notes to make sure that everyone hears the same thing. The staff will need to understand that they own their own solutions and that you will work with them to support them if they have something that you know is worthwhile. Personnel interviews allow the staff to explain what is really happening at the facility. The group interviews build on a different range of perspectives, while the individual interviews really allow people to open up. This also gives experienced personnel the chance to identify historical problems. After the tour, there will be an in-depth inspection of the site, based on the results of the kickoff meeting and of the walkthrough tour. After the tour, you will go back and revisit the facilities that you're supposed to be doing the E4 on. You might start in the basement and work your way up to the roof, or you might start from the roof and work your way down to the basement. Generally, you could follow whatever the technician or tour guide thinks would be best for them. It's generally best to address the biggest problems first. You will likely get the most bang for your buck by using this approach. You should employ diagnostics as needed. Diagnostics could include thermographic images or the use of data loggers. Data loggers are employed over a certain period, and data is collected later to record things like on and off sequences on equipment, lighting levels, or temperature levels in the spaces. As you walk around, you will check gauges and controls and question why a return air temperature is what it is versus what you think it should be. Then you will inspect the building systems themselves. You will be opening air handling units and looking at seals and things of that nature. During the facility walkthrough, you should talk to the staff and the occupants about the history and the changes in the building. You should be observant and use all your senses. Make sure to read gauges and the indicators carefully and try to schedule the tours at the facilities during the unoccupied or off-peak hours. A good example would be if you are doing a dormitory. You want to check the dormitory during the day when it's generally unoccupied. Or if you are looking at a kitchen, doing it during the off-meal hours, so that you're not being intrusive into their operations. Next, we will go over examples of a facility after tour walkthrough. Let's see what we find. So as we are walking down the hall, we open the entrance door, and the first thing we do is we look over the offices where all the desks are. You see a personal heater in an office. This indicates that something's wrong with the facility that requires high-intensity electric space heaters. So what could have changed? Have the control sequences changed on the air conditioning systems? Or maybe the seals are bad on the windows and doors and there's too much air coming in causing drafts. These are the types of questions we need to be asking ourselves. Next, we leave the office area and walk down the hallway to a mechanical room. As we look inside the mechanical room, the first thing we notice is the maintenance on some of the equipment. You can see that the bearing on this fan is overgreased. The concern here is that overgreasing a bearing can be more detrimental than undergreasing it. We want to try to figure out what the root cause of the problem is. Is it a lack of training on the part of the technicians? Or maybe the maintenance technicians are not getting the training support they need from management. It's possible that the sequence of the maintenance schedule has changed. It could be any number of things, and these are the things we would be looking for in an E4. Next, we leave the mechanical room and go down the hallway to the finance office, where we see a woman working with her coat and gloves on. This is not an uncommon situation to observe. What could have changed over time that now causes this woman to have to wear a coat and gloves to do her work at her workstation? It could be any number of things, such as maybe there's a draft coming in through the windows or doors. This would require additional investigation. Next, we walk into another mechanical room, and immediately we are impressed with the pristine conditions inside. However, after opening one of the air handling units, we see filters that are all broken up inside. Again, we would ask the question, what happened that led to the mess of filters? Is this due to lack of training of the technicians? Or maybe the building managers were trying to be cheap here and put a very cheap type of filter that is inappropriate for this kind of air handling unit. Maybe the filters are missized and we would need to get the correct size for the unit. Another question that comes up concerning these filters is how widespread this problem might be. Perhaps we ought to pull covers off other air handlers as well. These are the type of questions we should be asking. Next, we walk into a third mechanical room and see a steam pipe which is uninsulated. The temperature gauge is reading 132 degrees Celsius. So we make note that a possible measure is to add insulation. Another issue to note is that there is a concrete deck above the pipe and there is a second floor to the building. So as long as the pipe is not insulated, it will be radiating heat and increasing the heat load on the second floor. We point this out to the technician and he makes a note to take care of the situation right away. We'll look at the air handling system next. You can see where, for one reason or other, the technician decided to tie off the damper. They said they did not have the time or the materials to take care of the situation when it was observed, so they tied it off. It has probably been like this for years, and it makes you wonder what the effect is on the entire control system if this is tied off. How much energy is being used down the line as a result of doing this quick fix? So we add this to the list. Next, we look at a fan motor which is missing a belt. The remaining belts appear to be slipping, but no one has remembered to replace the missing belt. This is not that unusual and represents an out-of-sight, out-of-mind situation, which can lead to a large wastage of energy. The motor is standard efficiency and might be 40 years old. It has been rewired multiple times at great expense. The motor rewind was probably the cheapest option, but they might now have to put thought into the long-term costs of operating an old motor. They should consider upgrading using premium efficiency motors instead. We leave the mechanical room now and walk down to the gym area. We see somebody is airing out their shoes and insoles on this supply register. This is a supply register on the bottom and the return register is on the top. The shoes are introducing an obstacle to the supply system. We leave the gym and we walk down to the next mechanical room and we see filthy filters and coils that are causing air blockage and reducing system efficiency. Next, we enter one of the laboratory areas where there is a walk-in freezer unit. On the table, there is a specimen that requires lighting a minimum of 12 hours a day. So we talk to the researcher, and the researcher assures us that they leave the lights on 24/7 and that the extra lighting doesn't hurt the specimen. Her concern is strictly on the research, making sure that nothing harms her specimens. However, following some discussion, we were able to convince her that the right thing to do is to put timers on this particular unit so that after 12 to 13 hours of lighting, the timer switches the lights off and then on again when the lighting is required. We turn the corner into the storage room and here we see shelving stacked floor to ceiling with all kinds of things, not only equipment but specimens as well. The facility staff say that they were considering spending thousands of dollars to put in a dehumidification system because the room is just not getting the airflow that it needs and it's very humid in there. So we look at it and make two recommendations. First, remove everything from the top shelves, which is a no-cost solution. We also notice two air chillers in the room opposing each other at opposite corners. We suggest turning them so there is counterclockwise flow of air. With the top shelves no longer blocked and relocation of chillers, we now have good circulation and have eliminated the need to install a dehumidification unit. Next, we walk into the cafeteria area and decide to look above the ceiling. Here, we see a fire damper that is still wrapped in its plastic. We learn that it's been like this for 7 years and it was never commissioned. So we point this out to the facility staff and they assure us that it will be taken care of. Also in the cafeteria, we look at the walk-in coolers and freezers and can see from the infrared image that there's an opening that needs to be sealed. Next, we look at the belts through the entire facility and we see that the typical use V-belts. If they use cog belts, they could save as much as 5% due to lack of slippage and less resistance. And in the last photo here, we have a situation where there was a water leak, and rather than fixing the leak, the staff have used their ingenuity to collect the leak so that it goes down the drain. So now you would have all this information and you'd have your notes, and the first thing that you would do at the end of each day is to complete a brainstorming session where you would review your observations to develop a preliminary list of energy conservation measures, or ECMs. During the outbrief, you would ideally have the original facility team as well as the senior management and other participants and stakeholders present. The first thing to do during the outbrief is to recognize the champions, the people who have brought to the site the best ideas with regards to energy savings and making everything work the way it should be working. You should acknowledge and praise the good practices found, and you should give a list of the preliminary findings to the site so that by the time you leave, they will have an idea as to the types of findings to consider. So in review, during the discovery phase, you will have held the kickoff meeting. You will have held the walkthrough tour. You will have looked at the facilities in detail and uncovered root causes, and you will have provided your preliminary findings during the outbrief. Next in the process is the correction phase. Let's look at what is involved. In the correction phase, you'll look to the next steps in implementing the improvements based on the list of findings. During this stage, you will be doing an in-depth analysis and reviewing the documentation and details. You will be reviewing the findings made during the inspection and spending a lot of time on the cost analysis of potential solutions. Going through and doing the site evaluation is a relatively easy task. It's once we get back to the office and start the analysis that things become a bit tougher. The goal of this stage is to develop a list of ECMs and then prioritize the list. You will, of course, be trying to identify low-cost and no-cost ECMs. There are many facilities that have limited access to any funding, so it's important to identify as many low-cost and no-cost ECMs as possible. You will also identify ECMs that require capital investments. The idea here is to provide justification for putting in project submissions. You will also want to prioritize the ECMs based on the greatest payback. By the time you are going back in the office and going through the analysis, the site will have been briefed not only on the ECMs that you are looking at, but they will also know just from our walkthroughs with the technicians what kind of things can be done immediately. So you should first find the site will have already begun making their no-cost corrections to the facility within days or hours of your leaving. During the corrections phase, there will have been an in-depth review of the documentation, a review of the findings and identified ECMs, and the site will have hopefully begun implementing their no-cost, low-cost solutions. The site will have developed a measurement and verification plan so they can see what the impact of the ECMs are. They will have taken measurements before the changes are implemented and will take measurements afterwards so they can evaluate the impact. Finally, we'll talk about the handoff phase and what is involved there. During the handoff phase, you will see if the site has updated the facility systems documentation based on the E4 findings. It is a good idea to do this while everything is still fresh in their minds. The site should have also updated their documentation and revised their O&M manuals and checklists. You will work with them to prioritize the list of findings in the report, and then usually after a period of 6 to 12 months, you will revisit the facility to see what progress has been made. While the E4 is still fresh, this could be an opportunity for the site to update their O&M manuals and checklists, to revisit their preventive maintenance routines, and possibly draft a retro-commissioning plan. The final report itself should be organized so that it is very self-explanatory and user-friendly. Your typical final report will include an executive summary in table format at the front of the report. The report contents should begin with background information about the facility itself, how old the building is, usage, hours of operation, and things like that. There should be a section on equipment inventory which describes specific equipment, age, manufacturer, power consumption, and so on. The report presents data analysis and the energy conservation measures recommended. And finally, the report will include appendices for calculations, assumptions, and references. The executive summary will be sent to senior management and should include a succinct overview of proposed ECMs. How senior management uses the report is up to them. It could be used as a general guidance document for future efforts, or it could be used as a precursor for a more in-depth analysis, especially if the recommendations include retro-commissioning or an EPC. It could be the basis of different financing opportunities, or it could be used as a starting point for the development of new projects. As mentioned earlier, it's a good idea to follow up after 6 to 12 months. This is both for the information of the auditor and for the facility. The handoff phase may also involve staff training. Some facilities want the training to occur after the site evaluation. The handoff will also involve the handoff of system documentation and updated procedures, the final report, and then a checkup after 6 to 12 months. In summary, the E4 is a proven process for effective results. It takes a common-sense approach to finding solutions. It's focused on finding root causes, correcting the problems, and implementing low and no-cost solutions, and some of them will include capital improvements. Successes and opportunities will be shared across departments. The next slide provides some resources you might find helpful. We've provided the NRCan Recommissioning Guide and NRCan's Guide to Energy Auditing. Finally, we will go over 10 quiz questions to test what we've learned in the course. Question 1. The Energy Efficiency Expert Evaluation is a hybrid of A. An energy audit and retro-commissioning, B. An energy assessment and an investment grade audit, C. Retro-commissioning and an O&M review, D. An energy assessment and an EISA metering study, or E. None of the above. The answer to the first question is A. An energy audit and retro-commissioning. Question 2. Energy efficiency expert evaluations are being implemented in Canada to A. Reduce energy use intensity at federal buildings, laboratories, and other facilities. B. Help the Government of Canada's operations cut their greenhouse gas emissions 40% by 2025 compared to 2005 levels. C. Provide an alternative to traditional building audits that combines the benefits of both an audit and retro-commissioning. D. A and B are correct. Or E. A, B, and C are correct. The answer to question 2
is E. A, B, and C are correct.
Question 3. Which of the following best describes the role of the facility operations team during the energy efficiency expert evaluation? A. Identifies building environmental concerns that are critical to mission, suggests potential solutions, and implements low-cost, no-cost energy conservation measures. B. Leads the energy efficiency expert evaluation team through the 4 stages of the process. C. To provide objectivity, the facility operations team is brought into the process once energy conservation measures have been identified. D. Performs all functional and diagnostic testing and provides results to the rest of the team. E. None of the above. The answer to question 3 is A. Identifies building environmental concerns that are critical to mission, suggests potential solutions, and implements low-cost, no-cost energy conservation measures. Question 4. Because of the many benefits, a preferred recommended practice for establishing the evaluation team is A. Use internal staff to reduce costs. B. Contract with external consultants. C. A and/or B. And D. None of the above. The answer to question 4 is B. Contract with external consultants. Question 5. Prior to the kickoff meeting, circulate a questionnaire to identify A. Key players for the energy efficiency expert evaluation team. B. Metrics for the measurement and verification process. C. Recurring issues and concerns. D. All of the above. Or E. None of the above. The answer to question 5 is C. Recurring issues and concerns. Question 6. The primary purpose of the initial building walkthrough is to A. Observe and get a general sense of the environmental conditions, facility conditions, scope, and tempo of operations and management climate. B. Get a feel for what spaces and conditions are served by the equipment and systems that the team will be commissioning. C. To informally talk to staff, occupants, and users to learn more about the work environment. D. All of the above. Or E. None of the above. The answer to question 6 is D. All of the above. Question 7. When reviewing the master list of findings to determine recommendations for improvements, the energy efficiency expert evaluation team should consider A. No-cost or low-cost solutions. B. Cost versus benefit. C. Budget and project funding options. D. All of the above. Or E. None of the above. The answer to question 7 is D. All of the above. Question 8. Which of the following can you expect from an energy efficiency expert evaluation? A. Prioritized list of energy conservation measures. B. Identification of problem root causes. C. Easy fixes that yield immediate results. D. Implementation plan that results in energy reduction. Or E. All of the above. The answer to question 8 is E. All of the above. Question 9. Which of the following should be analyzed using utility bill information? A. Trend the usage of energy, steam, and other energy sources. B. Review tariffs, rate schedules, and identified meters for appropriateness. C. Identify problem areas or unpredicted events, such as large spikes in usage. D. Adjust occupancy habits, operations, operating hours, and schedules. Or E. All of the above. The answer to question 9 is E. All of the above. Question 10. As a result of the energy efficiency expert evaluation, energy conservation measures, A. Document equipment operation problems found in the evaluation. B. Identify energy efficiency opportunities. C. Are prioritized based on simple payback. D. All of the above. Or E. None of the above. The answer to question 10 is D. All of the above. Here is our contact information if you have any questions concerning energy efficiency expert evaluations. Thank you for participating.